The argument is that extraordinary claims require extraordinary evidence. What it should say is that extraordinary evidence requires extraordinary funding. So when you're not funding the search for equipment from other civilizations,
right,
then you will never have extraordinary evidence.
Really excited to have you here because, you have done extraordinary things, the least of which I would say was lead the department at Harvard for many, many years, written several books. And your most recent, I think this is the most recent one, was about the event in 2017.
I had a textbook called Life in the Cosmos, published in June 2021. The extraterrestrial, is not a textbook, it's for the general public, and it was published at the end of January 2021. But that's the one that you probably want me to discuss.
We are just excited to hear from you. We want to understand your perspective on what else. And Jesse, we were talking earlier, and one of the things that I read of his is he said, when we look up at during the day, it's one thing, but when you look up at night, wow, and sort of, Anyway, so why don't you just start to tell us, first of all, how you even became consumed with the work that you do?
I was working throughout my career mostly on, how the first stars formed, the scientific version of the story of Genesis, Let There Be Light, and later on black holes. And then in 2017, there was a very unusual object that was spotted near Earth. And it was the first object that came from outside the solar system that we noticed near Earth. And it was discovered by the Pan-STARRS survey, a telescope, in Hawaii on Mount Haleakala in Maui. And it was given the name Oumuamua, which means a scout in the Hawaiian language. And at first, astronomers said, well, it's probably a comet, because comets are those icy rocks that arrive to us from the outskirts of the solar system. And if another star passes near the sun, it would dislodge some of these icy rocks from the solar system. And you can imagine the same thing happening around other stars. So if there are interstellar objects that float in interstellar space that are not bound to a star, they are most likely to be comets. The only problem is that when a comet comes close to the sun, it evaporates, the ice on the surface sublimates, becomes gas, and you see a cometary tail of gas and dust. They're mostly water vapor and some dust. And there was nothing like that around this object. There was no cometary tail. And in fact, the Spitzer Space Telescope looked very deeply for carbon-based molecules, couldn't see anything around it. So it was definitely not a comet.
That when you became aware of it, did somebody call you and say, what about this? When did you become aware of this object?
Well, it was discovered on October 19th, 2017. And usually when a discovery like that is made, there is a circular, an announcement before a scientific paper actually appears. And I saw that because a decade earlier, I wrote the first scientific paper trying to forecast how many rocks should we expect from other planetary systems floating in interstellar space. And we didn't expect Pan-STARRS to find any. So in fact, by many orders of magnitude. So the mere discovery of an object was surprising because we didn't expect any. So that's why it attracted my attention. But then as time went on, this object looked weird because people said it must be an asteroid, just a rock bare rock without any ice on it. The problem is that as it was tumbling around, the amount of sunlight reflected from it changed by a factor of 10. So it meant that it has a very extreme shape. And when fitting the variation of light as it was tumbling every 8 hours, it looked as if at the 90% confidence level, it's most likely flat, pancake shaped. That's unusual, an extreme shape that is flat. And then this object exhibited an excess push away from the sun by a mysterious force that is pushing it away. And the force declined roughly inversely with distance squared. And since there was no evaporation, it couldn't have been as a result of the rocket effect. So the only explanation that came to my mind was the reflection of sunlight. But for that to be effective, the object had to be very thin. sort of like a sail. Just a year ago, the same observatory in Hawaii discovered another object which shared the same qualities as Oumuamua. It was also pushed away from the sun by reflecting sunlight and had no cometary tail around it. But the observers, within a few weeks, realized that it actually came from Earth. If you go back in time, this object was actually launched out of Earth in 1966, and it was part of a lunar lander mission. This object called 2020 SO was just the rocket booster of that mission. So it was not designed to be a sail, it just had very thin walls. And because of that, it had a large area for its mass, and it was pushed by reflecting sunlight. And also, we know that it was artificially made because we made it. NASA made it.
Right.
The only question is who made Oumuamua? So, that was the question I addressed in a lot of publications since Oumuamua was discovered. And of course, I got a lot of pushback for that. And that's the subject of my recent book, Extraterrestrial, that was published in January 2021. The argument is that extraordinary claims require extraordinary evidence. That was stated by Carl Sagan. And my point is that this argument is wrong. What it should say is that extraordinary evidence requires extraordinary funding. So when you're not funding the search for equipment from other civilizations,
right,
then you will never have extraordinary evidence. And, we would never discover gravitational waves from collisions of black holes unless the National Science Foundation provided $1.1 billion to the LIGO project. And in fact, we've been searching for the nature of dark matter, which makes most of the matter in the universe. We don't know what it is. It's not ordinary matter of the type that we are made of. And we've invested hundreds of millions of dollars in the search for specific types of particles that theoretical physicists envisioned, such as weakly interacting massive particles. For 40 years, we've been searching, investing hundreds of millions of dollars. Nobody in the mainstream said, well, we should never discuss weakly interacting massive particles because there is no extraordinary evidence for them. Therefore, we should not fund those searches. These searches were funded as part of the mainstream, and we haven't found anything. And nobody says it was a mistake to fund this search, even though we haven't found weakly interacting massive particles. So what I'm saying is, if we invest hundreds of millions of dollars in the search for equipment from other civilizations, just because we send such equipment into space, and we know now that half of the sun-like stars have a planet the size of the Earth, roughly the same separation, and most stars from billions of years before the sun, so they had plenty of time to launch equipment. If there were civilizations out there, they could have done it a billion years ago, and by now populated the entire galaxy. And, there may be packages in our mailbox. We just need to check. Now, if we don't search for that, obviously we will not have extraordinary evidence. So it's a circular argument. And I should add, in December 2021, President Biden signed into law a legislation by the Congress, the US Congress, to establish an office in government that would look into unidentified aerial phenomena. These were reported exactly half a year earlier in a report from the Director of Intelligence, the Office of the Director of Intelligence, to Congress, talking about objects whose nature they cannot figure out. And these were detected by multiple instruments. They were looked at by the intelligence community, and they just cannot figure it out. So Congress said, well, let's coordinate the data assembly, make sure that people do not feel that there is a stigma on reporting about such objects, and let's establish an office that will have funding. And the office will be administered by Department of Defense and by the Office of the Director of National Intelligence. The government is the most conservative organization that we can think of. It's really, to me, quite puzzling that the government is taking it seriously, whereas the scientific community is lagging behind. And so I established the Galileo Project in July, a month after the ODNI report to Congress. I established a project, scientific project, because a number of wealthy individuals came to the porch of my home and offered me altogether a few $1 million to my research fund at Harvard without me doing any fundraising after they read my book, Extraterrestrial. And that allowed me to establish a new project called the Galileo Project, which searches for equipment from extraterrestrial technological civilizations that may be floating near Earth. And that includes two branches of research. One is to look for an object like Oumuamua. So it's like you went on a date and you liked who you dated, but that person is not around anymore. Oumuamua is now 1 million times fainter. We cannot go after it. We cannot search for it. We cannot look at it. So you are trying to date the next Oumuamua. Okay, so by date, I mean, this is a very expensive date. It costs $1 billion. The idea is to send a camera that will come close to the next object that looks as weird as Oumuamua was, and take a close-up photograph, because a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. If we had an image, I wouldn't need to write the book. It would be easy to tell if it's a natural object or an artificial object. So that's one branch of the Galileo Project, to design such a space mission. And of course, select objects of interest. And, you know, it's just like, again, the analogy of a date. If you think about someone that you might want to marry and have an offspring with, you want to get as much information as possible about that person before committing. And the same is true about sending $1 billion mission close to an object. What you want is to make sure that this object is sufficiently weird. It's not looking like a comet or an asteroid. So that's one branch of the Galileo Project. And the second is looking for unidentified aerial phenomena, the UAP, that were reported to Congress, and trying to figure out their nature. And we are planning to build the first telescope system on the roof of the Harvard College Observatory in the coming months, and then make copies of it, depending on how much funding we have altogether, and distribute them throughout many geographical locations, and basically collect scientific data on these objects and clear up the question of what's their nature. You see, the government owns data that is classified, and you know, people within government looked at it. For example, the head of NASA, Bill Nelson, he said that the hair in his back stood up when he saw this classified data. We cannot see that data, but we can look at the sky. The sky is not classified, and collect similar data, and it will be open to the public, and we will publish scientific papers that will analyze it in trying to infer what the nature of these objects is. That's the Galileo Project.
I have to say, you were talking about extraordinary funding. It's extraordinary thinking that we're missing. I think that's the key, right? You're asking a question about something. I'm really curious, though, why you do think that the mainstream scientific community in this field is determined to keep it like this. What are we holding on to? What are we afraid of if we ask some of these questions that they're asking? That's one question. And the other one is, weren't there photographs from what NASA or the Department of Defense released? Jesse, didn't we see some of those? It was like we never saw.
What we saw is just the tip of the iceberg. You see, there are photographs. They look blurry. They are not conclusive, but the convincing data is classified because the government owns the sensors that were used, and we just don't want our adversaries to be aware of the sensors monitoring the sky, right? So as a result, the government keeps the cards close to its chest and does not release that data. But it's not that the data itself is necessarily classified. We can look at the sky. There is no law forbidding us from looking up, right? So astronomers do it all the time. The only thing is, astronomers are focusing on very distant objects. If a bird flies above the telescope, they ignore it. The Galileo Project builds a telescope system such that, first of all, it would look at the entire sky all the time. We'll take a video of the sky, both in the infrared and the optical. We just finished the design of the kind of system. And you take a video of the sky, and then if you see an object of interest, you track it. And you have artificial intelligence algorithms that will try to identify the nature of the object, whether it's a bird, in which case I don't care much about it. If there is a high resolution image of a bird, I'll transfer the data directly to a zoologist. It's boring as far as I'm concerned. If we catch, for example, a drone that says made in China or made in Russia, I'm glad to immediately email that data to Avril Haines, no problem. It's as boring as a bird as far as I'm concerned. But if we do see something different that originated from outside of this earth, then obviously it has nothing to do with the borders between nations. Okay, right. So it's not a matter of national security. It's a matter of international interest.
What do you think that Oumuamua was? It was obviously, something couldn't live in that necessarily, right?
Oh, no. I have very little doubt that the most likely encounter we might have, if we ever find for sure extraterrestrial equipment, it will be with a system that at best has artificial intelligence, not biological creatures, because we were not selected by Darwinian evolution to survive in space. The stories we hear from people like Elon Musk that there will be a large community of people living on the surface of Mars within the coming decades is just, it cannot be realized, because if you put a person on the surface of Mars just for a few years, a significant fraction of the brain cells, will be destroyed in the head of that person. No way
because
to
we can't survive the radiation.
Of very energetic particles. You have to live in caves at best, to protect yourself. There needs to be a solution for the health of humans. And obviously, it takes a huge amount of time to make a journey between stars. So you would never send a biological creature. It would never survive the journey that may take millions of years with chemical rockets. So the most likely encounter would be with equipment that may have artificial intelligence. And we shouldn't look down at artificial intelligence because it's driving cars for us right now. Right. And in the future, there may be AI astronauts. Astronauts that are equipped with artificial intelligence, not people, and they can perform much better than humans can, because they will be able to process much more data much faster, and they might learn from experience, like through machine learning. So if we can imagine such a future for the equipment that we send out, a civilization that predated us by 1 billion years may have done that already. So I think it's most likely we will find equipment that it could be very intelligent. We might need our own AI systems to interpret their AI systems. The sender may not be alive anymore, but it's irrelevant, because this equipment is autonomous. It learns from its own experience, it behaves on its own, and it was just provided with the blueprint, with some task that it needs to fulfill, and we need to figure out its intent. And just like relying on our kids to interpret content that we find on the internet because they're more computer savvy, we might need our own AI systems to interpret their AI systems. Coming back to your question first, what do I think Oumuamua was? The way that science is done is that you put possibilities on the table and then try to get better data to dismiss some of these possibilities. Now, my colleagues dismissed the possibility that Oumuamua is an extraterrestrial piece of equipment, and they said it must be a rock. Okay, now, after saying it must be a rock, there were 4 separate groups of scientists that tried to explain the anomalies of Oumuamua, and they all came up with a rock of a type that we've never seen before. For example, a chunk of frozen hydrogen, a hydrogen iceberg. So when it evaporates, you won't see the vapor because hydrogen is transparent. The only problem is that such an object will get evaporated very quickly, and a hydrogen iceberg would not survive the journey. Then they said, okay, well, maybe it's a chunk of frozen nitrogen, like that was chipped off the surface of a planet like Pluto. And the only problem with that, there is not enough nitrogen available to produce enough chips, and that's a mass budget problem. And then there was a suggestion, maybe it's a cloud of dust particles that are very loosely bound, so it's 100 times less dense than air. The only problem with that is, even so, the idea is that it's so fluffy that by reflecting sunlight, just like a feather, it will be pushed away.
So when they're detecting it, the telescope in Hawaii, how far away is this object?
It was a fraction of our distance from the sun, about a third of that. So it's quite far away.
Far away.
And at that distance, with the Pan-STARRS telescope, we can only detect objects that are bigger than a football field from the reflection of sunlight. So there might be many more objects that are much smaller than Oumuamua passing through, but we don't see them because they reflect much less sunlight. So my point is, if all the proposals that were made by mainstream astronomers to explain the anomalies of Oumuamua invoked something that we've never seen before. We've never seen a nitrogen iceberg floating in space. We've never seen a hydrogen iceberg. They just invented it to come up with the qualities of Oumuamua. Imagine a caveman finding a cell phone, and the caveman is used to playing with rocks all of his life. So he would argue at first the cell phone is just a rock of a type that I've never seen before. That's what he would.
Right.
And then now, if he would behave just like the science community does right now and say, okay, I figured it out, throw it away. It's a rock of a type I've never seen before. If we will never try to get more data on it, then that will be a self-fulfilling prophecy. It's a circular argument. You say it's a rock of a type. Okay, so anything.
But why do you think there is? But my question to you is, why is there a rigidity to the way you're describing it anyway?
Yeah. So there are several reasons for that. One is, is clearly explained by the reaction of one of my colleagues who was an expert. He studied rocks in the solar system for several decades. And when he heard a lecture about Oumuamua at Harvard University, when we left the room, he told me, Oumuamua is so weird, I wish it never existed. Okay, so now you think about it, what does it mean? It means that an expert who is used to analyzing objects in the sky as rocks, when confronted with an object that doesn't look like the rocks he's used to, is upset about it. Why? Because he wants to maintain the reputation as the expert in the field that knows how to explain anything that is observed out there. Okay. So when you see anomalies, that shakes the belief that he knows everything. What does an expert mean? That when faced with any new data, the expert will be able to explain it. And there will be nothing major missing from the point of view that the expert has. Okay, so that's one aspect of this. The second is that when you approach something that is different, you don't want to take a risk, because again, you are risking your reputation. To interpret it as in terms of something quite unusual, like an artifact from another civilization, would be risky, because if it turns out to be natural, then you lost your reputation. So that's the other aspect. Then the third thing is the public is extremely interested in this possibility that it may represent a smarter kid on our cosmic block. Okay, so the public cares a lot about it. There is a lot of speculation about unidentified aerial phenomena, what they might represent. There is a lot of science fiction literature. And so the scientists want to distance themselves from any discussion that may appear to be speculative or that has a lot of nonsense attached to it just by people that are not professional. The way I see it is, 1,000 years ago, there were lots of people that for religious reasons or other reasons argued that the human body has a soul. And as a result, anatomy should be forbidden, because if you were to dissect the human body, you would hurt the soul. That was an argument. And so imagine scientists throughout history saying, oh, there is a lot of nonsense. I don't believe the human body has a soul as something independent that you can hurt by dissecting it. But so therefore it's nonsense. But I don't want to taint my image by doing operations on the human body, because then it's as if I'm engaging with a falsehood about the human body or something. So imagine, where would modern medicine be if scientists would distance themselves from the human body and say, we just want to work on the question of how many angels can sit on the tip of a pin, or let me rephrase that, how many extra dimensions are there, or what is happening in the multiverse in regions of space and time that we can never visit, ever, not only during our lifetime, but ever. Let's talk about that, because there is no risk there. We're not talking about something that anyone can test, and we can talk about it forever and do mathematical gymnastics. Let's just talk about how many angels can sit on the tip of a pin. Then you have to think about how to frame the mathematics of an angel sitting on the, okay, so we can develop a whole field of mathematics out of that and demonstrate that we are smart in the process of doing that without risking anything, because angels may not exist. So you can talk about it, you can demonstrate that you are smart and never take a risk. So the fact that scientists deviated from being reluctant in engaging in studying something that the public cares a lot about, that a lot of nonsense is said about, the fact that scientists were willing to engage in that brought a lot of benefits to humanity. And I'm saying, when you learn about reality, not virtual reality, not talk about things that show that you are smart, but rather things that the public cares about, things that will teach us in which cosmic environment we live in. It's completely reasonable to consider the fact that we are not special. We should start from a humble point of view, from humility. So reality doesn't really care about who is being liked on Twitter, who is being liked by the church, who is being liked by the political system. There is a reality out there, and we better figure out what it is. What I hope will happen is if we find a smarter evidence for a smarter kid on the block, all the small differences among us humans will appear meaningless because there is someone much smarter than we are. And as a result, I hope that we will treat each other with respect as equal members of the human species.
Thank you so much for coming on and enlightening us in a way. But I would say that we started this conversation with, I said, did you see Don't Look Up? And I would say, after talking with you, look up. Let's see what's up there, right?
That's exactly the message in the opening paragraph of my book, Extraterrestrial.
I know, I know. Maybe in a year from now, if we're lucky enough to be here and haven't left, we can have you come on and let us know how it's going. It sounds like an extraordinary project. So grateful for you for joining. Thank you.
Thank you for coming on very much.
Thanks for having me.